Hello, grade 9 students. Welcome to a new chemistry chapter entitled Electron Arrangements in Atoms and the Periodic Table. In this session, we'll cover the following objectives. You need in this session your chemistry guide, a chemistry notebook, and a pen. Let's consider a hydrogen atom. How is the electron moving around the nucleus? Great, it's moving in a definite path. It's moving in a space called the electron cloud. But what about atoms having more number of electrons? Let's consider a calcium atom. In the nucleus of this atom, we have 20 protons and 20 neutrons. But what about the 20 electrons? Do they move randomly around the nucleus? Sure not. Also, they don't move on the same path. In fact, the electron cloud of an atom has a layered arrangement. These layers are called shells, orbits, or energy levels. Scientists have identified 7 energy levels till now, but in grade 9, we'll be limited to the first 4 energy levels. The first energy level for n equal 1 is K. The second energy level for n equal 2 is L. The third energy level for n equal 3 is M. And the fourth energy level for n equal 4 is N, where N is the shell number. The arrangement of electrons in the electron cloud is called electron configuration. But how to write the electron configuration of an atom? In fact, there are 3 general rules that are taken into consideration when writing the electron configuration. Regarding the first rule, from which shell we have to begin distributing the electrons? Can we start from any shell? The location of the electrons in the electron cloud depends upon how much energy the electron has. Electrons with the lowest energy are found in the energy level closest to the nucleus, which is the energy level K, while electrons with higher energy are found in the energy levels further from the nucleus. That's to say, the energy of the first energy level K is less than the energy of the second energy level L, less than that of the third energy level M, and less than that of the fourth energy level N. Rule 1 says that an electron will always fill an orbit or shell with lower energy and then occupy the higher energy once. Then electrons will fill the K shell, then L shell, then M, and finally N. Let's now identify the second rule. How many electrons can be placed in each shell? Does the number of electrons vary with an orbit? Rule 2 says that only a fixed number of electrons can be filled in each orbit, depending on the orbit number. And by applying the formula 2n squared, we can calculate the number of electrons, where n is the orbit number. But pay attention, you don't have to pass to the next energy level before filling the previous one with the allowed number of electrons. So by applying the formula 2n squared, the number of filled electrons in the K shell, where n equal 1 is 2 electrons. The number of filled electrons in the L shell, where n equal 2 is 8 electrons. The number of filled electrons in the M shell, where n equal 3 is 18 electrons, and that in the N shell, where n equal 4 is 32 electrons. But rule 3 says that the maximum number of electrons that the outermost shell of an atom can possess is 8. So, level K can never hold more than 2 electrons, while levels L, M, and N can hold 8 electrons each. So as a summary, when writing the electron configuration, you must always obey the three mentioned rules. Rule 1. An electron will always fill an orbit or shell with lower energy and then occupy the higher energy ones. Rule 2. Only a fixed number of electrons can be filled in each orbit, depending on the orbit number, and we can use the formula 2n squared to calculate the number of electrons, where n is the orbit number. Rule 3. The maximum number of electrons that the outermost shell of an atom can possess is 8. Let's take now an example. Writing the electron configuration of potassium atom. Given that potassium atom having the symbol K has 19 electrons. So, 2 electrons will be filled on the K shell, 8 electrons will be filled on the L shell, another 8 electrons will occupy the M shell, and the rest electron will occupy the N shell. Thus, the electron configuration of K is K2, L8, M8, and N1. Dear students, now you have to solve 3 applications, and you can pause the video to try solving each one. In application 1, you have to write the electron configuration of magnesium atom Mg, whose atomic number Z is 12. Do you remember what does the atomic number Z equal 12 mean? It means that the number of protons in Mg atom is also 12. Can you deduce the number of electrons? Yes, in a neutral atom, the number of protons is equal to the number of electrons, which is also 12. Always in writing the answer of such questions, you have to mention that the atomic number Z is equal to the number of protons, and in a neutral atom, the number of protons is equal to the number of electrons, which is 12 in this exercise. Then the electron configuration of Mg is K2, L8, M2. Application 2 asks you to write the electron configuration of the following 20 elements. You can again pause the video and solve, then check your answers in the next slide. In application 3, you have to write the electron configuration of the following ions: O2-, Cl-, Al3+, and Na+ ions. In your answer, don't forget to write that the atomic number Z is equal to the number of protons, and in a neutral atom, the number of protons is equal to the number of electrons. For writing the electron configuration of O2- ion, we say that the oxygen atom O having Z equal 8 will gain 2 electrons to become an oxide ion. Then the number of electrons of the O2- ion is 8 plus 2 will give 10 electrons. So the electron configuration of O2- ion is K2L8. For writing the electron configuration of Cl-, we say that the chlorine atom Cl having Z equals 17 will gain 1 electron to become a chloride ion. Then the number of electrons of the Cl- ion is 17 plus 1 will give 18 electrons. So the electron configuration of Cl- ion is K2L8M2. For writing the electron configuration of Al3+ ion, the aluminum atom having Z equals 13 will lose 3 electrons to become an aluminum ion. Then the number of electrons of Al3+ ion is 13 minus 3 electrons to give 10 electrons. So the electron configuration of Al3+ ion is K2L8. Similarly, for the sodium ion, the sodium atom Na having Z equal 11 will lose 1 electron to become a sodium ion. Then the number of electrons of Na+ ion is 11 minus 1 will give 10 electrons. So the electron configuration of Na+ ion is K2L8. Dear students, keep in mind that the atom is made up of nucleus and electron cloud. Around the nucleus we have 4 energy levels. The first energy level is K, the second is L, the third is M, and the fourth is M. And the arrangement of the electrons in the electron cloud is called electron configuration, where the K energy level can hold only 2 electrons, while the energy levels L, M, and N can hold 8 electrons each.